Because of the very special form, because this Cobb-Douglas production function is homogeneous, it turns out that the demand curve for capital depends on cost and the price of capital. And of course, your cost is going to depend on all the inputs that you hired. So that's how we get back to quantity in there. And so the demand for capital is inversely related to the price of capital and so on and so forth for the other inputs. And then from there, you can substitute the demands back into the production function and solve for cost. So you get cost on, solve for cost on the left hand, take the first line at the top of the screen and solve for cost, get cost over on the left hand side, because output minus all that other stuff should be 0. So you solve for cost and you get the next line, which is transcendental and includes the different prices and output. So the factor price cost frontier has on the right hand side all the prices: price of labor, price of capital, price of materials, price of fuel, and output, and a bunch of coefficients, just like it's very much in the nature of the one that I gave you in your homework assignment. Now this is a factor price cost frontier for a very specific production function. And so our job out in the cold, cool world is to not impose a particular production function on the data, but to let the data inform us about the characteristics of the production function. We believe that such things exist, production functions, but I don't know what the true parametric production function is any more than I know whether or not it was a big bang or a big bounce that started the universe. Okay? And so as a consequence, I do know, however, that whatever my specific example is that I want to use, it's going to have this form. So we could get from that very specific parametric assumption about production to the sort of thing you had in your problem set by doing a Taylor series expansion on that factor price frontier. But the Taylor series expansion that we come up with would be true regardless of what the underlying production is, because in the one that I gave you, the gammas, or there are 3 characters I used in the one that I gave you, gammas and alphas, those are derivatives of the unknown production function, evaluated at the data points. That's what produces your estimates of those coefficients. And by looking at how those coefficients behave, we can infer whether or not the underlying production function is homothetic or exhibits homogeneity in prices or exhibits homotheticity. And we can know all that without knowing what the specific production function was. And so that's the power of statistics, is being able to infer something at a very general level about the underlying truth, rather than assuming the truth and then trotting out some data to say that these results support the truth. The truth is that what's been discovered over the years is that because economic and finance data is so regular and so smooth, the Cobb-Douglas production function provides a great fit to any data that you come up with. So it always looks good. However, when you take this approach, which admits any specific production function, then things don't look so good for Cobb-Douglas. It's too restrictive. Okay? Could I, or did I? I was going to make it part of my answer key, which I haven't done yet. Why I think it's important to know this at some point. Knowing this wouldn't help. Seeing this wouldn't necessarily help you much.
It wouldn't hurt. No.
Excuse me?
It wouldn't hurt.
No, it wouldn't hurt you. This I can do. I can put that on. It won't hurt you.
Well,
Know it. Maybe it'll add some context to what you're doing. Probably everything that you need to know to do the homework is in that picture, and being able to interpret what's there. Yeah, there's a ray from the origin, and the slope of the isoquant is the same. Whatever isoquant you pick, the slope where the ray crosses the isoquant is the same. Always the same. And it can be any ray, which means that while it's prices that determine the slope of the isoquant, output has nothing to do with it. When it comes to returns to scale, given the prices, output is determinative of returns to scale.
so orthopedic.
No, I said the ratios of the factor demands, which are derived from the first order conditions. Those ratios can vary with prices, input prices, but they should not vary with output. And you can see here that the first order conditions all depend on Y. So you've got to know something specific about B1, B2, B3, B4 in order to make sure that the marginal rate of technical substitution doesn't change without the same thing in the homework assignment.
So that's the first order condition for our specific homework is being met.
Hang on. No, this is a specific example that I came up with. This down at the bottom of what I was just showing you. This is the factor price cost frontier for a Cobb-Douglas production function. We could estimate the unknowns, the b's in here, using nonlinear least squares. However, in estimating this as the factor price cost frontier, we have said that the underlying production function for the world is Cobb-Douglas. Suppose we don't know, or we're not willing to presume that it's Cobb-Douglas. And we still want to know something about returns to scale and homogeneity and so on and so forth. Well, then we have to have a flexible functional form that will accommodate all underlying production structures. And that's what's in the homework assignment. So I think we're done with that.